Hi, welcome to part one and two of my presentation. In this part of the presentation, I'll first go over the three things that I learned from this project. So the first four things actually that I learned from this project is that I learned how to retrieve system resource data and save it to a local file. I learned how to encrypt the system resource data when uploading it to a remote S3 bucket. Learn also decrypt the system resource data when downloading from a remote S3 bucket. I also learned how to implement my own standalone RC4 encryption and decryption algorithm. Now I will go over how to set up and run my project. So to set up run my project, I'll first go over my RC4 implementation, standalone RC4 implementation. So I have uh, implemented my entire RC4 implementation um, in this main.cpp file. And when I open this file, you can see that this entire code or entire file takes in some parameters. For example, the file in, file out, and encrypt boolean, and then a salted boolean to identify whether you encrypt with the salt or not, and then a user key. So in order to run my RC4 implementation, I would compile this file and then this main.cpp file, and then I run it. So in order to demonstrate, I could open my terminal, and then I can do gcc or actually g++ main cpp, and then actually I've already compiled it, I think. Let me see if I have compiled it. So c4.sol again, g++ main.cpp, then out c4 dot out, then lssh, and then lcrypto. So after I compile it, I think it should be ssl, I think. Yeah, now it's compiled successfully. Now I'll run my rc4.out file, and without any argument, to look at the type of arguments that this my standalone rc4 implementation takes. So I will run my rc4.out without an argument. So here you can see, let me just clear this out. Run it again. So here you can see this file rc4.out takes in the file in, file out. So file in is for if you're encrypt or decrypt your file in, and the file out would be the output. And then like your user key, he provides salt or no salt, and then encrypt or decrypt. So this is the RC4, my standard RC4 implementation. Now I'll go over the SDFS implementation, how to run and configure that. So in order to configure SDFS implementation, I mean SDFS part, to do that, first clone the repo, the SDFS Fuse repo, where I have cloned it in a folder called SDFS Fuse. So after I clone that into this folder, I'll open a terminal to show us. So after I clone it, I will make the changes and then install S3FS after I finish all cloning. And then I'll try to mount my SDFS bucket by running sudo S3FS with all of the information, like for example, I think if I have it here, I will, yeah. Okay, I think I don't have it here. So all the informations like the password file, the um, uh, the bucket name, etc. So after I do that, my bucket will be mounted. So bucket will be mounted in folder called this AWS S3. After that, I drop and I upload files, and it'll get encrypted, and when I download it, it'll get decrypted. So in the later part of the presentation, I will demo my RC4 implementation and also the S3FS Fuse application. So this is the end of the part. Was one second, first and second part of the my presentation, and thank you for watching. Hi, this is part three of my presentation, and in this part, I'll be demoing how I wrote a shell script that helps me retrieve the system resource data of my operating system, or the processes that are running in my computer, and how I receive the data and save it to a local file. So in this part, I'll first go over how the shell script that where I wrote the code that's accessing the source data, and then I'll go over how it's saving the data to a local file. So first of all, I'll go over the shell file here. So here's this shell .sh file. In this shell file, this code is relatively small because I'm using a built-in Linux command to get the process information or system information, and with a little bit of tricks where I'm getting the information the way I want it. So first here I am specifying the output file name here, which is the file name is system.res.txt, and which is currently empty here. If we look into it, so I'll do a demo running it, and then all the output will be saved to this file. And then this is a target size. This target size means that I'm specifying the number of bytes that this file should, the number of bytes of data, or the bytes of data that this file should have, or um, I'm I'm want to collect. For example, if I'm saying is 1024, so that means that I want to collect around 1024 bytes of process system data or resource data. So the reason I am specifying this one here is because in the later part of the presentation, when I'm demoing my RC4 standalone implementation, I have to the project requires me to use 100 use a file that's at least 100 kb. So here I'm actually using this file to do the R7 implementation to showcase that. And here I added this file size so that it's easier for me to look at a file which is 100 kb, more than 100 kb, or at least one of the 100 kb. So that's why I added this one. So after this line, I'm running a while loop. And this while loop actually with no condition, it's like true, it will run entire time, and then infinitely. And in line 10, I'm checking the current size of the file, of the output file, by running the command du dash b. And this entire line is getting the current size of the system res.txt. Size means like the number of bytes this file has. So then in the if statements, I'm checking whether if the current size is less than the target size, which is the bytes that I want, the total bytes of data that I want in the output file. If the current size is less, then I want to keep getting data. I'm getting the resource system data about my computer. Um, and I'm getting those information by using one of the Linux. It's an inbuilt command in Linux. It's called top. So normally, if I run this command without any arguments like b/bn or one, this command will just give me the process in real time where it updates, and it does not terminate. So now, now since I only want the data, a snapshot of the data, and I want to save it to a file, I have to run it in a way so that it gives me a one like a snapshot, and then it exits and it terminates. And after it terminates, it saves all the data to a file, which is output file, which is held by this variable output file. After that, I go to the else break when if the current size is actually greater than the target size. So let's say if I already have 1024 bytes read already in this text file, then I'll just break out of the loop. And then after that, I will have to do sleep, is because when while the if statement is running and not there, when I'm not reaching the else yet, I, I have to make sure that I'm not calling the top command without, like, I have to wait after I call the top. So I'm waiting here 1 second. So if I call right away, if I call the top commands continuously right away, without waiting, then it'll give me an error. So I mean, basically, you'll overload the system. So that's why I'm waiting 1 second for to call the next I'm calling the next hop by waiting 1 second every time. So after that, after the while loop is I'm breaking out of the while loop. I'm just outputting output file generated successfully. So I'll just do a short demo of this file. So first, before I running it, I'm going to go out to this file so that to make this shell script while executable, I'm going to do chmod plus x and then system sh. Let me see. Chmod. I'm gonna run this again. I think it worked. Command chmod. X. Yeah, so I think I've already did it, so I'll work it now. So I'll just run this command system dot I'll actually res dot h. So to run this command, this will this isn't working. System red dot sh. Should be sh. Sh. Here, it gave me all the outputs or the data that will be returned normally with the top command. But here it's not updating. It terminated at the end. It's because of this two arguments that I provided here. So it just gave me a small snapshot, and I'm getting around 1024 bytes of data in here. So this is the part three of my presentation, and thank you for watching. Hi, this is part four of my presentation, and in this part, I'll be demoing my AWS S3 bucket implementation. I'll be demoing the encryption on upload and also decryption on download. First, I will upload a local text file which contains the resource data, like operating system resource data that includes like the number of tasks, memory, and so on. I'll upload that file in my locally mounted S3 bucket. I mean S3 S3 bucket, and then I will download that same file from from AWS console, which will be encrypted. After I download it, I will decrypt it, and then I will run a diff command to make sure that the decrypted is same as the original one that I uploaded. Now, for the next one, for the decryption and download, I will first encrypt a file locally and then upload it manually on using this console on the browser. After that, I'll read it from my directory, locally mount AWS directory. Um, After that, I will check whether it has been decrypted in my locally mounted directory. So I will compare the file that I read from here to my local file, which is system res local. So to start, I'll first mount my directory, SWS S3 directory. So I will do this. Okay, so now my directory has been mounted successfully. My best bucket has been mounted, and now in order to for my project, which is a proposed project, not the default one, I had to um, I had a file which stores the information on your operating system, such various information on operating system. So my goal was to get those information and then upload to a S3 bucket, encrypt it, and then show the download, also decrypt it when you download this file. So in order to demonstrate that, I will first run a script. So here, this is the file. This is currently empty. This file contains all the information, or the couple of information that I'm getting using a built-in command called top in Linux. So that command will give you the top command will give you all the some of the informations about processes, memory, and so up, and of your about your operating system or your computer. So this is currently empty. I'll run a script to generate those data. So in order to do that, I'll let's say the script is actually called sh systm system message. Now it says output file generated successfully. So I'll go look into the file. So if I have a look into this, so I'll just reload. So this is the file that I'll be using to demo the upload and download using the bucket in my S3 bucket. So first, I will upload this in my mounted as Amazon S3 directory. So in order to do that, I'll first I can just do, let me see if everything is correctly, my mounted directory is correct. So I'll just drag and drop it over here. Now I'll reload it on my on the AWS console, which I already did this part. Now I will download it. So I'll reload it in here, and it says the system res uploaded.txt. Now I will try to open this. Since this file, when I uploaded, it was not encrypted. It was plain text. Now in this console, this file should be encrypted. So when I try to open it, it should basically download it and start opening it, because this is an encrypted file. So I'll open it in the folder. I'll actually rename it so that it's easier for me to. This is, I'll say system res upload encrypted system as upload encrypted, yeah, and then I will drag it and put it over here in my desktop so that I can view it. If I cat this file, sys res upload, this file is encrypted as it's shown here. Now I'll try to this the next part is I'll decrypt this file, and then I'll compare this file with the file that I uploaded in Amazon S3, in my local mounted directory. For this one, I will use to decrypt this file. I will use my standalone rc4.out, which is my standalone rc4 implementation. So in order to look into that, I will first yes, and so this is the structure of of how I implemented it. So first, it takes in a file, and then a file out, and then a key, a salt or nozzle, and an integrated. So for this, since I'm going to decrypt this file, and I haven't made this in a way where if you include a file out, the file already has to be created, because it does not create it if it does not exist. So in order to do that, I'll first create the file that will hold the decrypted text. So since this is encrypted, so what I'll do is that sys res and then upload, so decrypted, so as upload decrypted .txt. So this will hold, yes, okay. Let's see, I think about somewhere here. So as upload, where is this? Chat over here. Okay, now what I'll do, I'll run my rc4 implementation. I'll do rc4.out. After that, my file in is, I'm going to decrypt, right? It says res upload, and then enciy. So this is the encrypted, the first one. The second one would be the where the actual text will go on. The plain text will be, which is the decrypted one. So it'll be upload decrypted. The next thing comes out is the key. My key is this. This is what I've hard coded. And then no salt, and then decrypt decrypt. As I'm decrypting it, now this file would be actually the plain text file. So this is the uploaded file, and this is the plain text file that I just decrypted using. And now in order to do that, I can also run a diff command against this res, and then upload decrement, and this one, and then the folder that's inside Amazon S3. So for that, I will do text top slash S3. And let me see this. I think I have to do this. Yeah. Since this didn't return anything, that means the file inside the file that I uploaded from before in my locally mounted bucket is same as the one I downloaded from the console. So now, so first part is done. Now the second part where I'm going to demo how the decryption and download. In order to do that, I'm going to do first. I'm going to make a encrypted file locally with the standalone RC core. So since um, to do that, I can again generate another. I can run my script again to generate the updated tasks or the resource data. For that, I can open this one. So this is the last one. So I will just save it. I don't need this one. So this is system res.local.txt. Since this is what is this? Not This is empty. I'll run the script, which is on. I have to fill this up. System. Okay. I think I have to update the script. So let me see. So I will rename the script with something else here. So instead of with the uploaded one, I should be now system res because I want to fill in the local one. So save it. Then I'll run it again. Now if I look into this one, this file has been filled with some data, some resource data. Now I will encrypt this file. After I encrypt this file, I will upload it in using this console and here in there. So to then to encrypt it, I will use my rc4 dot out. I also have to create the file before I encrypt it. Which doing hold the because I'll create to touch. So yes, res 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 download e encrypted dot text. This is to hold the encrypted data. What is this one? This is to hold the encrypted data, store the encrypted data, and then touch this restore the encrypted data. After that, I'll just also create another file that will also hold the decrypted data so that I can compare my download whether my download and decryption and download work perfectly. So I'll do system res download text, which is this. Now what I'll do is that I will, since this is the local file, which is normal plain text, I'll encrypt it and put it in the system dot res download encrypted, which is now empty. After I encrypt this one, the result will be stored in this file, and I'll upload this file, and then I will try to read it from here, and then I will see that and compare this one with this one, and then I'll compare this one. So I guess I don't need this one. So let me just encrypt this one and this one right now. So I'll use my rc4 dot out. The file name is syn res local, and then the second file would be the file that I'm gonna store the encrypted text, res download and download encrypted.txt, and then my key. Let me see this. Okay. After my key, I am going to do no salt. Since it's no salt, I'm doing it with no salt. And then I'll do ncrypt. ncrypt. So now if I look into this download encrypted file, they'll say that this file is encrypted, right? So I'll upload this file, and then I'll try to read it from my emergency. I'll upload it here, drag and drop, and upload. Then I close it. So now it's already in here. So I'll try to now to check whether this file, what is this one? I think it's the second one. I think so. This file has, if I did it from my mounted directory, should be decrypted. So do that. I will go to my Amazon S3 directory, and then I'll do ls, and it gives me the downloaded encrypted one. So what I'll do is that I will first caret sys res down okay downloaded encrypted.txt. So this one I uploaded an encrypted one. Since I'm reading from my locally mounted, it should be now in plain text. So yeah, it's in plain text. I'm gonna do another one. So this is in plain text. I'll clear this. So now I'm gonna do also. I can also do another diff between this local and then the one that I just read from by uploading and using the console. By uploading this file using the console. So I can do a diff command from or against this two file system res local thing. Mm, okay, I have to go. I think directory out uh, system local, and then the second one would be inside desktop, or actually not inside Amazon S3. So it'd be I think so I think it should be this S3. Is it working? I don't know. Something like that. I think S3, and then the name of the file is sys res, and then download dot encrypted, and then I'll do this. Since here it didn't return anything, so that means these two files are same. So this is the part 4 of my presentation, and this is the end of this presentation. So I've went over how I'm doing an encryption on upload, and also I also shown how to do decryption on download. So this is the end of the presentation, and thank you for watching. Hi, so this is part 5 of my presentation, and in this part I'll be demoing my RC4 standalone RC4 implementation, where I'll be showing how to encrypt and decrypt a file first without salt, and then to make sure whether those encryption and decryption work correctly, I will run a diff command against the input and output file, and after that I will show the same encryption decryption algorithm, but instead of without salt I'll be doing it with salt, and to verify that I will do a diff command again similar to the last one. So to start, I will first show the input file that I'll be used to encrypt and show the for implementation. So this is the input file here. This file is storing all of the system resource data in my computer, and to look at the size of this file size, I'll go to this folder. So here in system res.txt, this is the name of this file. And if I go to the properties of this file, I'll see that this is this file is at least 100 kilobyte, which is the requirement for this project. um, so now I will start demoing my encryption algorithm. So to start demoing, I'll open my terminal, then I'll clear my run, and then first I will compile the main.cpp file. So my entire code is in main.cpp file. So if I do an ls, so in this folder I have a main.cpp file. So I'll first compile this. So this is the code where I did the um, uh, actual implementation. So I'll do g++ main.cpp, and then I'll do out file would be, let's say, um, rc4 rc4.out. After that, I have to include the libraries that I'm using. So it would be SSL, I think. I'm not sure. I might get kernels, and then CRY PTO. And then I'll do run. Yeah, it was compiled correctly, and I'll clear the. Now I'll clear it. So to start implementing, so I'll first demo it, demo the encryption and decryption algorithm without the salt, and after that I'll do it with salt. So to show it without the salt, I will. So the input file would be. So I'll start with rc4 dot out. Now I'll before I start with the entering the arguments, I will show you the structure I made. So if I just run it without any argument, it shows that I need a file in and file out and key, and then one of the options, or there's salt and no salt, and other I'm encrypting or decrypting. So to that, I will start with rc4.out, and then my input file is now sys res dot txt, which is this file right now here, and then. And then my out file would be a file. I already have created this file, so this file is currently empty here. You can see that this file is currently empty. So what I'll do is that I'll encrypt this file with no salt, and the result would be stored here. So this file would be entirely encrypted. So now this file name is res and then enc no salt dot txt. So this is the input and output file. I put it in, and then the next argument is the key. So my key I'm providing as my name and then some numbers. After that, I'll say that it's no salt because I'm doing this one first. So no salt, and then I'm encrypting. So here yp okay, encrypt CR, okay, and CRYPD. So now if I click on it, if I run this, let me see. Oh, I think I made a mistake here. So it should be rc4.out, not comma out. So rc4.out. If I do that, so you can see that this resulted. This is the ciphertext where everything is encrypted, and this was the actual plain text, and this is everything is encrypted with no salt. Now, I will decrypt it. In order to decrypt it, my file in would be this file, and then the file out, which I already also I already have created. So this would be the file out for no salt decrypted decryption. Since here it's shown as empty, it'll when I run the decryption algorithm, it'll be similar to the plain text algorithm. So plain text file or the original file. So now I'll do rc4. Let's see rc4 dot out, and then the input file will be as res the encrypted one, which is enc, and then no salt alt, and then .txt. So this is the input file, which is the encrypted one, and then so this is so it's the encrypted no salt, and then the output file will be as res and then decrypted no salt .txt, right? After that, I'll provide the same key. The key has to be same because otherwise it wouldn't be encrypted. I won't be able to get the actual plain text. My key was POL 1 2 3 4. What was it? POL 1 2 3 4. Yes. For that, I'll say that it's no salt. I'm decrypting with no salt, and then I'll do DECRYPT decrypt. When I do that, right now it gave me the actual original plain text. So now to make sure whether those so I'll do this command right now, to diff command to against the input and output file. So now to make sure that like this is, since this file is really big, it's really impossible to go through all of them. So I'll run a diff command to make sure that they're actually same. So that will actually compare the original file with this decrypted file. So I'll do a diff and then sys res .txt, and then I'll do sys as res decrypted no salt .txt. Then when I run it, see, and since there are no outputs or no prints, terminal didn't show anything, that means they're same. The encryption and decryption, then no salt encrypt and decrypt work correctly. So now I will be demoing the same algorithm but with salt. So in order to do that, I will first my input file will still remain the same. Um, right now. Let me see this. So I'll just clear this output here. The rc4 dot out, that should be dot out, and then the input file would be same sys res dot text, and the output file I already have created it similar to the no salt one. So here it says it's currently empty because it's not integrated. So the name is res encrypted salt or txt. So now I'll type it in here. So sys res enc encrypted salt.txt. After that, the other argument, the next argument is the key, which is poll 1234, and then the other argument is salt, and then encrypt crypt. So after I do that, let's see, system address. This is the input, and this is the output. Salt, and then this shows me the output now. To make sure that this is the salted one, you can see that at the top, or there it says that there is salted, salt, it says it's salted, and then there are some characters after that. So salted, the characters after the salted are those random bytes that are used to, like, generate a random key. So yeah, so it says that it's salted. So so if you see that if you see that this file is salted, that means that the key after the salted should be used to retrieve the actual key, if you want to decrypt the file. So in order to so right now I will try decrypting it. So to decrypt it, I'll pass this file. This file as an input, and then the output file would be this file where this is currently empty, and then this should result as the same one as the original one. So I'll do also put out. So the input file would be sys.res encrypted salt.text, and then the encryption, the output file says res decrypted salt.txt. After that, I'll provide the key that I've used to encrypt, and then I'll do salt and then bcrypt. Okay, and just make sure that I don't have an error. So I said rc4.out systhread encrypted salt.txt sysres decrypted salt.txt. So this is the output file. So just this one, and then I have the key, and then salt and decrypt. So if I click on, so it looks similar to the original text. So now, to make sure that this is done correctly, I'll run the diff command again. So the similar way I did the last one. So I will compare this file, which is dictated with salt, with the original file that I had. So I'll do diff with sys res dot text, and then sys res decrement salt.txt. So after doing that, I see that there is no output. That means that those two files are decrypted correctly, or those two files are same, and then this file has been this file which has been encrypted with salt has decrypted correctly. So this is the end of the part 5 of my presentation. So thank you for watching.